everyone. Welcome back to Mars Day 2021. We're delighted to have with us today Andy Aldrin, who hopefully is going to appear on the screen in a second.
All I can see is Tom.
I know.
Where's Andy gone?
Sure
Maybe he has to...
Oh,
there he is. I think I've got to put you on some other kind of view.
There we go. Now we can see Andy.
Okay.
Welcome, Andy. Thank you so much for...
Hello, Susie Dallas. It's great to be here. Just great to be here.
We may be Zoomed bombed a little bit later on by Jim Green, just so you know.
Oh, that would be fabulous. Jim's an old friend. I'd love to talk with him.
He was jelly. We said, we're going to be talking to Andy Aldrin. He said, well, why aren't I talking to Andy? I'm like, all right. We may increase our group, but it's lovely to see you. We've been talking about Mars all day, and it's an absolute pleasure to have you. We're on to the Americans now. Andy Aldrin, Jim Green, all as we get later and later into the evening.
Sophia Mitchell.
Yeah, Sophia Mitchell will be talking to at JPL. Yes.
A little bit later.
6:30.
Fantastic.
Anyway, big news, of course, as we talk about Mars Day. We're a month on since Perseverance landed. I just wanted to quickly, before we go on to other stuff, talk a little bit about your thoughts on that. Excited or more of the same? Is this a big paradigm shift? Are we going to find exciting things? Where do you stand on that?
It's something in between the two, because it's a fabulous mission. It's exciting the way we get there. I spent a lot of time in the launch business, and I'm used to living in a world where the most exciting part for the principal investigator of the mission is the first 7 minutes of launch. And so it's always been kind of a relief to know that I didn't have the most dangerous part of the mission for Mars missions. So, and the sky cranes are just fabulous. The rover is fantastic. But at the same time, it's building on the base of science that we've created over the last decade. I mean, we've learned a tremendous amount about Mars, and this mission is exciting because every mission we talk about the possibility of learning something which really kind of tells us that there might have been, tells us that there was life on Mars, and that's one of the really existential questions of humanity. So yeah, it has to be exciting.
Yeah, I mean, and it's an existential question we've been asking a long time. I mean, the sort of history of Mars exploration, we go all the way back to to Viking. I mean, Viking had an astrobiology component to it. I mean, it was sort of looking for the sort of components of life. We obviously didn't find, although there was some interesting news from Viking. I seem to remember.
No, there were some tantalizing clues that we should really bring Jim into that conversation, because he was front and center for all of that. There've always been tantalizing clues. And so at what point do the clues become enough of an edifice that you say, we've got a building there? Yeah. Right? And we really know. There's a chance that it'll come from this mission, but it's also setting the framework, the foundation for actually caching a sample and bringing a sample back to Earth, which I think will be just really fascinating.
Well, I think that's what sort of lots of people have been asking us about today, is why isn't Perseverance bringing back the sample? And obviously there's more to it than, you can't land a rover, get the sample, launch it back in one go and bring it back to the Earth. It seems to be the beginning of a much larger program. And,
Well, yeah, I mean, think about launching. I mean, it's a huge operation to get to Mars, and it's going to be a huge operation to get back. And so, you literally have hundreds, in some cases thousands of people working on a launch, just to get something to Mars. And you've got one little rover to kind of manage a launch. It's just too hard to do. It's too hard to do in one mission. I think it was, this whole architecture was looked at for a long time, to come up with the sequence of missions that would get us there.
Yeah, I mean, the stuff that I'm looking forward to is what's coming up. This idea that another rover is going to pick up the samples that Perseverance has left, and then launch a rocket from the surface of Mars to an orbiter and then back. I mean, it's
launch a rocket and the samples will go into orbit, and then they'll be collected and brought back again. And then what happens when they get back? Thinking about the fact that these samples are going to return from Mars. We don't know what they contain. How do you deal with them? All the containment issues associated with samples from another planet. It's just fascinating.
It is. So we look forward to all of that. And
I know the thing is, it's not. I want it to happen now.
Yeah, well,
today.
sorry.
It's like, hurry up and do it.
Takes a while, for sure.
I mean, for you, you obviously work in education and you do a lot of outreach stuff. And I know you've got your giant moon map that you take to, and also you've got a giant Mars. And I'm wondering what's the more popular? What gets kids most interested in space? Is it the moon or Mars or somewhere between?
It's Mars. It's Mars.
Yeah, there is something about Mars, isn't it, that just represents the kind of, not the final frontier, but it's really as kind of as far as we could imagine.
It's hard to imagine sending people beyond Mars. It really is. At least with current propulsion systems that we've got and the technology. And it's even hard, to think about Jovian moons or things like that, which would be kind of the next really interesting step.
Yeah,
scuba diving on Europa, which I would love to do, but that's not going to happen in my lifetime. But the thing about Mars that, from an educational standpoint, is so great is when you think about Mars, when you start to get sort of serious about having some kind of permanent habitation, not necessarily a million people like Elon is going to bring a million of his best friends up there, but just sort of an Amundsen Scott station with a few dozen people in it. You realize that you're not going to be able to take all of those people home or bring them there in one mission. So you're going to have some kind of rotation. So people are going to be there for probably a decade. And so now you're talking about living on Mars, and you can't just camp. You can't bring everything with you as you could for a couple of years, maybe. And so when you start with that premise and you bring it into the classroom and you say, okay, we're going to have to live on Mars, you start thinking about, you have to do everything that you do on Earth on another planet that at certain times is 2 years away, right? It's, you think about it, the 7-Eleven, the grocery store is 2 years away.
Well, that's it, yeah.
So then you get teachers thinking about different lessons. I mean, you can teach construction, you can teach plumbing, you can teach anything on Mars, and it's more fun and interesting for kids.
Yeah, exactly. I wonder, actually, if you don't mind, can we go all the way back in time? Because you're someone, obviously, you've grown up really with the entire history of human space exploration. Were we having these conversations during the Apollo days? Were people even back then talking about going to Mars?
Oh, absolutely. I mean, if you... I was 11 years old when my dad went to the moon, so I wasn't talking about it all that much. But, as a scholar, I've been thinking about space for, most of my adult life. And so you look back, and we were planning to be on Mars in the 1980s, right? And I mean, that was serious. Those were NASA's plans. It was, the gospel as promulgated by the Saint von Braun. And that's what we believed.
Von Braun was interesting because he, a little bit like Elon Musk, he had his own Mars project, Das Mars Project, which was the same thing of we're going to send flotillas of spaceships to Mars. But even that rocket behind you, that hugely overpowered Saturn V, was originally in von Braun's mind a Mars rocket.
No, but no, it wasn't. The Mars rocket was a Nova rocket, which was twice as big as that thing. It was. I mean, this was von Braun's medium lift vehicle.
Yeah.
Okay.
And so,
but he had Mars in his sight.
One of the interesting things about von Braun and a comparison with Elon Musk is, even though he worked in a government bureaucracy, von Braun was very much an entrepreneur. He built an organization. He defended the boundaries of the organization, and he took a lot of ownership of what he did. It was rockets were his field, and he owned that market, if you think, even within a government bureaucracy.
Yes, I should point out, in case you're wondering, who Werner von Braun, in case you're wondering, was the sort of the primary architect of the Saturn V rocket that we see behind you, which took Andy's dad and some other people to the moon. But actually, it's quite interesting when you said you weren't thinking about it at age 11. Were you not really impressed by? I mean, when I was 11. I'm slightly younger than you, but not much younger than you. When I was 11, all I could think about was going to the moon. I could draw the Saturn V in the margins of my school books. I knew the names of every astronaut. I just, I was obsessed by it. So, but for you, presumably it was a bit normal and a bit kind of like every day.
It was. I mean, we lived in a house at the end of the street. So it was one of these pie-shaped lots. and there were 5 houses behind us. 3 of them were astronauts.
Yeah.
You could not swing a dead cat in my elementary school without hitting an astronaut's kid.
Yeah.
So, I mean, we were all over the place. So it was normal. And it was, I had absolute faith in NASA and everything that was happening. But, you know, it's like, Dad's going to the moon. Okay, well, it'll be a long trip before he gets back. But okay. We'll see you in a couple of weeks, Dad.
Yeah. Did you meet people like von Braun? Had you met
Not von Braun, no. I mean, I probably met and have forgotten more people than I should have. But, you know, there was an opportunity to meet lots of interesting people. I just wish I were smarter at the time.
No, that's the question. Yeah, that's the thing. I mean, he's kind of a controversial character. Tom Lehrer, the musician, you might remember Tom Lehrer, wrote a very disparaging song about Werner von Braun.
Oh, did he?
He did. But yeah, there are similarities between, well, I see the similarities between people like Werner von Braun and Elon Musk, these kind of visionary people, you know, with Mars as a destination. It's like, this is where.
Well, it feels like Mars has been 30 years away for 30 years, I guess. And so that's why people are asking, when are we going? When are we going? People are keen.
Right, it's kind of like nuclear fusion.
Yeah, exactly. Right? We'll solve it soon. It's okay. But talking about Elon Musk and those sort of space entrepreneur tech billionaires, you know, what are your thoughts about where things are going in the future? Because the story, certainly for many of us, has been quite dominated by the space agencies over the years. But, you know, in the future, things may be different. So what do you think it's going to look like, our industry, in a few years' time?
So the honest answer is I don't know, but we could be on the brink of a complete change, you know, to a sort of commercially dominated paradigm where most of the investment, most of the business comes on the commercial side. And there are a lot of great indications, but, you know, overall today is probably the most exciting time in space, certainly, you know, in my short life, but for young people that are growing up today, it's just an amazing opportunity that, you know, anyone in any of your classrooms could be applying for a job working on the moon. Because when we go to the moon with Artemis, the purpose is to stay there, and to stay there because there are good economic reasons to do this. Because you can use the moon to supply the rest of space. Probably won't bring things from the moon back to the Earth, but it'll become a source of fuel, it'll become a source of materials to build things in space. And so, you know, kids in elementary school today could be applying for jobs, you know, working as a welder on the moon. It's not just going to be astronauts.
Kids in elementary school.
Really, it's going to be a place where you go to work.
Kids are already designing like sort of small satellite systems already in the classroom. It does seem, and partly because of the digital revolution, but partly because we're all part of this amazing conversation now with social media and whatever. We feel part of something in a way that in the past we weren't. Government agencies what government agencies did rather quietly and not in secret, but we didn't have access to it.
So we've been doing some work with the school in Egglescliffe in the UK. Somewhere around Newcastle, I don't know, the whole, you know, I forget. So you've got kids that are maybe 12, 13 that are building satellites. I mean, they're the 2-inch by 2-inch chips, but it's actually a satellite. It has all the functionality of Sputnik, and they're actually satellites that have a fair amount of functionality that are called thin sats that are about like this, and you can send them up hundreds at a time in CubeSats. And so the cost of launching these things, it comes down to something that is reasonable enough that you can bring into the classroom, and you can have a class building a satellite, sending it into space. And, you know, by the time, maybe you don't do it all in 1 year, but by the time they're in their second year, they're literally tracking their satellite in space. And
it's amazing.
How exciting is that?
Can you just talk a little bit about what we mean by cube satellites? We hear this term a lot, just for those who maybe aren't familiar with the term. And
so a CubeSat is 4 inches by 4 inches by 4 inches. And it was something that was developed at California State University, San Luis Obispo. I think it was one of the first places. But any university, they just wanted something that students could build and get into space. And it's become kind of an industry standard. And you have companies, Planet Space, which is building Earth observation satellites, sticking, I think, 6 of these CubeSats together. And for a few $1,000s, they're building satellites that are in space taking pictures that you're seeing on the news. You know, a lot of the pictures you see of, you know, Iranian missile installations or things like this, North Korea, are coming from planet space, and they're coming from satellites that are mixed, that are a set of these CubeSats that these guys who are all younger than any of us.
Surely not.
No, but I think.
Sorry, Dallas. It's true.
I mean, that's okay.
It's not hard to be younger than me. But,
no, I get it. Yeah.
At any rate, it's not. We have kids in high school that are building these CubeSats that are taking pictures of the Earth. And that it's a little bit more expensive, but the point is, any school can actually have a space program.
And it's a real shift as well, isn't it? You know, if you think about the missions, say the big missions, ESA missions, let's take Bepi Colombo, because it happens to be my favorite, going to Mercury. We're talking massive sums of money, 20 years of development. You know, it's like handcrafting a Rolls Royce, you know, and it takes hundreds of people and all these years, and we design it and we craft it and we send it lovingly off to another planet. And then what we're talking about here is so different from that, you know, the complete opposite, allowing.
But, you know, you can even do things like compare the functionality and do things that are functionally similar. So you talk about, you know, missions like, you know, going back to Surveyor, which if you convert it to today's dollars, I think was around $600 million. And we're sending some of the spacecraft that NASA is sending to the moon right now are $60 million missions. And so you're talking about an order of magnitude reduction in cost with probably greater functionality. And so those things are incredible. It's the opportunities are incredible. And that now we're just talking about things that are reducing the cost. But when we start talking about some of the commercial applications, we don't even know what we're going to be producing when we've got, you know, tens of companies that are producing satellites to do remote sensing, where, you know, we've got satellites that are just doing sort of standard multispectral imaging, but you've got satellites doing hyperspectral imaging, you've got satellites that are doing radar, you've got satellites that are tracking electronic signals, and you've got satellites sort of compiling data from Internet of Things. What happens when you start putting all of these data streams together? And we're just scratching the surface of the amazing kinds of data products that we're going to develop, information products that we don't even know about yet. And it's not, you know, the technology is all going to be on the ground for those things. Yeah.
It is amazing. I mean, you know, and so much of this so much of life on Earth now is dependent now on what we do on space. We just take it so much for granted. I think people think we're just putting stuff into space sort of willy-nilly, but everything from, like, as you say, remote sensing, looking back at the planet, looking back at the Earth, we can see so much and do so much with this technology, and it's only going to get better. And I think the democratization of space is really healthy as well. The fact that it's not just government agencies making decisions; it's like school kids.
That's true. But I think also there's a place for both, and I wonder if Andy would agree with me. There's a place for the space agencies. They'll continue with the missions that they do, and they're quite separate and different in many ways from perhaps the commercial opportunities that are becoming available.
Well, absolutely. And so it's, in some ways, it's normalization along with democratization. It's becoming kind of a normal economy. And in a normal economy, there are things where it's just economically more efficient for the government to do things because there isn't a sufficient market to justify the investment in it. And so those are the things that government needs to do. The industry will pick up where you can make money, and we're figuring out what those boundaries look like. And, you know, public-private partnerships are a huge part of this, and NASA's getting better at it. Sometimes we do really well. I think the program to resupply the space station, commercial resupply, is a perfect example of balancing risk between government and industry, and it's working really well. There are other times we haven't done so well with it, but I think over the next few years, I think you're going to see more and more things being done by commercial industry where the investment justifies it.
Yeah. I'm just flicking through the questions just to have a look. And thank you, Barbara's put in the Tom Lehrer song about Dr. Werner von Braun. If one's interested, I could sing it. I know it off by heart, but I won't sing it because that would be awful. I'm not very good at tell me. I can't remember the first line of the song. Please. I won't sing it. This one's from Ellen. Dr. Andrew, can you say that your father's occupation had a major impact on your childhood and career? If this didn't happen, what do you think would have been your career?
What?
So the answer is, undoubtedly it had some effect. But when I went off to school, I was fascinated by the Soviet Union, and so I pursued my passion, and I became a Sovietologist. I wrote my dissertation on how the Soviet Union beat the United States into space, which interestingly was a fascinating story of entrepreneurship. And just
I want to talk to you.
Place in the world that you would
I want to talk to you at length about this because I'm also fascinated by this. This is
okay.
But we won't. Maybe another time.
Yeah, we'd burn through the hour talking about this, but it's a fascinating story about how a group of scientists built the program from the bottom up, and they had this vision of going into space, but they had a government that really didn't know about it, didn't want to do it, but they managed to kind of, in some cases, deceive the government, trick them into funding the space program. It's a great story, But at any rate, the point was I pursued my passion, which was the Soviet Union, and that's what I was doing. And then the Soviet Union went away, which I thought was rather impolite of them to ruin my research agenda. And so I got invited because I had been showing aerospace companies around what was now Russia. And I got invited by one of them to come and work for them. And they paid me a lot more than I was making at the Research Institute. And so I got into aerospace industry kind of by accident. And I did that for a while. And I was an executive at Boeing and then United Launch Alliance and ran ironically, maybe not so ironically, a small company that was building a spacecraft to go to the moon. And then I kind of retired and went back to academia, which is what I do now. Between academia at Florida Tech and running the Center for Space Entrepreneurship, and then of course the Family Foundation, which we do space education. And I'm having a phenomenal time at what is, as I said, just a magical time in the development of space.
I want to find out a bit more about this.
So to answer your question, I don't know, and it's been, it's sort of an elephant or a moose on the table sometimes in my career, but I just pass the dishes between the moose's legs and don't really worry about it. So it probably had an effect. I'm just not aware of it.
I like that. I like that. We've got some of our STEM ambassadors who are going to do some questions. I think we've got Helen Shell is going to ask a question in person. Is Helen there?
Can you unmute yourself, Helen?
Hi.
Hi, Helen.
Hello. Greetings from Sunderland, which you have visited, Andy Alderin.
Yes.
I'm a visual artist and space science educator who specializes in STEAM methods. Mm-hmm. Now, I know a huge part of your foundation uses STEAM education methods. I just wondered if you would talk about it, why you do, and some of the projects that you work on.
So one word dropped out of your question, which seemed like a really critical word. You said, why you do, and then it dropped. So can you repeat that part?
Oh, okay. STEAM education.
Why STEAM?
Oh, sorry. STEAM, yeah.
Okay, so this is going to seem like a little bit of a digression, but one of the things that I've observed, and in fact my father observed as well, is that we do a really, really good job, particularly in tertiary education, of training engineers, the best engineers in the world. And scientists. We do a good job of that. What we don't do is a very good job of training leaders and training people who have a broader outlook. And to be successful in the world today, I think you need to be more than just technically excellent. You need to have a broad set of skills. And so I look at things like communication as being some of the most important skills that you can teach. I think it's important to understand more than just the technology. You've got to understand the social context of it. And so that's why we stress STEAM. And it's, I've mentioned briefly that this is one of the reasons that Mars presents such a wonderful opportunity, because on Mars, you have to do everything that you do on the Earth. And in fact, we did some research work at Florida Tech looking at long-term habitation of Mars. And one of the things that we realized is we understand most of the technology. We even understand the medical side of it pretty well. We do not have a clue how to keep people mentally productive, happy, even sane on a trip to Mars that might be a decade long. And so I think it's really important that you bring all of these things together. And we can call that STEAM, but I think it's just a broader context to education and understand the interaction between communications and technology, things like that.
Thank you, Helen. Was that a good answer? Did that answer your? Helen's vanished.
Yeah, I guess it answers.
No, yeah, an excellent answer.
That's okay.
And I
thank you, Helen, and we are so looking forward to coming out to. I think we're going to be out there. My people tell me they've locked me in for October or something like to come out there. We've had a wonderful time working with Egglescliff, and we've had great discussions with all of you. We're really excited about working with Sunder.
Yeah, we love you coming. We love you coming.
Well, that'll be great. Well, yes, we're looking forward to you coming back. I mean, do you think? I mean, you mentioned the sort of the psychological aspects of a trip to Mars and just the sheer length of time. Can you imagine in our lifetime boots on the Mars? I mean, like you say, we've been talking about it since the 1960s, and here we are. A long time later, and we're still, we've got to go back to the moon before we go to Mars. Do you think we're going to see boots on the moon, on Mars in our lifetime?
I do, but it's we're all sort of looking for a commitment to massive amounts of $1 trillion to go to Mars, and governments, and it will have. This is an area where it really does have to be the government. Unless it's just a purely charitable endeavor that some billionaire decides he's going to spend his billions going. But even that, I mean, when you talk about this Mars, you're really talking about hundreds of billions of dollars. Okay, and so that's just too much for a person. But if you think about it, so NASA spends roughly $10 billion a year that you can associate with human spaceflight. And if we focus that after we sort of develop a commercially self-sustaining presence on the moon, if we devote the majority of that money to a collective effort to go to Mars, and let's just say the rest of the world contributes another $10 billion of resources, however you count those, now you're starting to get to the kind of investment that it will take to get to Mars in 10, maybe 15 years from when you really start doing this. Yeah. And so, I see it happening. It is.
It is that thing of, where there's a will, there's a way, and where there's no will, there's no way. But people are always going to be arguing, and sort of understandably, if it's costing tens of billions of dollars, why are we doing this? Why are we sending people to Mars? Why aren't we spending that money on projects back here on Earth? And of course, that was the same argument that was happening during Apollo. People were criticizing Apollo at the time for, all the stuff that needs to be happening on Earth. Why are we sending people to the moon? But
Apollo is a very different thing, because Apollo was spending 4% of the total budget. Okay, that's a massive amount of money.
Yeah.
What we're talking about is NASA continuing to spend what it spends? Is ESA continuing to spend what they spend? Is China continuing to spend what they spend? I think, at least in the United States, where I'm somewhat more confident of the politics, there is I think a broad consensus, political consensus, that we should devote something like $20 billion a year on NASA and space, and sort of half of that goes to science, and maybe half of it goes to human spaceflight. And those numbers have been pretty consistent over the years. I mean, if something goes up $1 billion or down $1 billion, the lobbyists and people go crazy. But the fact is, if you kind of look at it in historical terms, it's pretty consistent money. And so what I would argue is that we just need to spend that money wisely. We need to focus on things, and we can accomplish a lot. And
I think also, you know, a big project like that, a bit like Apollo, it focuses the mind. I mean, Kennedy's famous speech about, you know, we're going to do these things, we're going to build rockets out of things we haven't even invented the thing yet. These kinds of things, you know, focus the mind and help people think creatively about how to solve a problem. And I think that in itself is such a fantastic thing for young people to think about, to get excited about something like a Mars mission and then try and figure out how to do it. And it just spurns off all these different careers and different avenues and different kinds of technology. You know, that in itself is an invaluable thing.
So I think you're exactly right, that we need to focus the resources that we have decided we're going to devote to human exploration to a clearly defined goal and make sensible decisions about how we're spending money. And we can do tremendous things. I do think it's unrealistic to kind of project the magic of Apollo onto today. It's a different world, and NASA is a different agency. What I think is an incredible opportunity is the amount of leverage that NASA can gain off of commercial developments that are going to happen because there are, for example, rational business cases to produce resources on the moon, right? And that can make a huge difference in how much marginal money the government really needs to spend getting to Mars.
Yeah. One thing that you mentioned, I just wanted to just pick up on. You talked about the Center for Entrepreneurship. Mm-hmm. And what is that and why is it important?
So the Center for Space Entrepreneurship was created in part, at least, at the initiative of a European organization in Strasbourg called the International Space University, which is an amazing organization. And I have a tremendous history with them. But they wanted to create a center in the United States that was looking at commercial space. And there was a competition, and we were selected at Florida Tech. And so we've created this center. The fundamental piece of it is a summer program that we run, which is it's actually a graduate program within the curriculum of Florida Tech. And so there are 4 courses which are full on, graduate courses that you would expect to spend, with 40 hours of time. And we do very serious educational work to provide a foundation for students to take if they're working, let's say, on a master's degree in aerospace engineering or a business degree or a policy degree. What we do is we give them literally a full semester of work in a summer that gives them the specialization in space. And so we teach them how to understand the real underlying factors in space markets, in space policy, where they'll understand not just what the policy of a nation is, what they build, but what are the underlying political and socioeconomic factors that enable them to do things or limit what they can do. And we have students who build business concepts. Actually, for them this last summer, I'm super stoked about this. This last summer, we have 4 student groups that are building, that are actually going to market with their ideas. One of which was selected for a very prestigious award and a bunch of money. I can't talk about the details of that group yet, but I'm super excited when I see our students out there doing things, and it's a constant learning process. But so we also have research that we're doing on industry emergence of various segments of the commercial launch industry. So I'm really excited about that program.
That sounds amazing. I'm going to rattle through a few questions because loads of questions are coming. I've been ignoring them and we've only got like 10 minutes. So this is from Ian Stevenson. Ian says, I think the acronym STEAM is hugely important as it uses the letter A. Do you think that art and design are important aspects to encourage creativity along with science, engineering and tech, all of which embrace maths for space exploration? I kind of think yes, but what do you think?
So the answer to that is absolutely yes. Yeah. It's the arts are a huge part of developing technologies and ideas that ultimately you have to sell these to people, whether it's governments. And so arts are a huge part of it, of being able to communicate the magic of space. Even if you're an engineer, you need to be able to do that. And so you need to understand kind of the arts as a fundamental part of that.
Yeah, no, I totally agree. And I think our explorations in space, it's part of wider human culture, and it's I mean, even you talked about the Soviet Union. You think about the Soviet space art, which was so fundamental in rallying that whole country. You look at those great murals that were painted in the Soviet Union. It was so much part of a bigger thing. So I agree. Very, very important. Eleanor, again, she wants to know, the impact that humans have had on Earth's environment is enormous. Considering that human emissions of greenhouse gases to be a major factor in global warming, could human life on the moon or Mars have a similar effect? Basically, how do we live sustainably on Mars? Well, I suppose, yes.
Well, I mean, hopefully we're a lot smarter than we were on the Earth. But I mean, the good news is there will be a lot fewer humans. The bad news is, I mean, particularly in the case of Mars, the cost of contamination are just astronomical. And we do pay a lot of attention to what we call forward contamination. And that is, if you have human devices on Mars, what we want to make sure of is that they're not contaminating the Martian environment, and just from a purely scientific standpoint, leaving some kind of traces of human activity that we would misinterpret, or that could kind of bugger up the data that we're getting. So we're very aware of that. If you talk about, kind of the broader thing of things like global climate change on Mars, I know there are people that are talking about terraforming Mars, and that's just incredibly ambitious. And I think you're not going to turn Mars into the Earth, and
no, unlikely.
No, I mean, it's something that to be concerned about, and fortunately, we're a lot smarter today than we were 200 years ago when we started this whole mess with global warming. And
well, you say smarter. Sometimes we're a bit smarter. Actually, just on that subject, someone Emma wants to know: will people start buying land on the moon or Mars? Actually, you make a good point about planetary protection. Of course, the laws about space are really, really interesting. Here we are talking about art and STEAM law and how all that works, who owns what, and a lot of those sort of treaties, the outer space treaty, are based on things like the Antarctic Treaty, that nobody can own Antarctica, and we have to protect.
So,
those.
I mean, it's a really good and really important question, and the easy answer is to say, well, treaties prevent you from owning land, and that is true. When we end up with self-sustaining commercial activity on the moon, it'll be interesting to see what kind of adjustments we make. And the important thing about the moon from a geographic standpoint, if you will, is there are small parts of the moon which are incredibly valuable. And specifically, you want to be on the edge of a crater that both has visibility to the Earth, so you can communicate, can see the sun, so you can get power from the sun, and is on the edge of a crater, because at the bottom of the crater, the really fascinating thing is the bottom of the crater is permanently in the shade. And so these areas are some of the coldest spots certainly in the solar system, where it's, maybe 20 degrees Kelvin, 20 degrees above absolute zero. And so those are really valuable because that's where the ice is. And so you want to be where you've got those three things. And there aren't many spots on the moon. So you've got kind of 1%, maybe 0.5% of the moon that, if you want to think about real estate, that's sort of like the center of London. And you've got the rest of it, which is like the Sahara Desert, and so those valuable bits are going to be things which there will be real political and legal activity trying to decide how to allocate those valuable bits over the course of the next 20 or 30 years. It's not going to happen today. My personal view is we should really figure out what's going to happen before we start imposing legal restrictions and frameworks that are going to prevent us from doing things. And it's, we didn't create the Outer Space Treaty until we were flying in space. So I think that's going to be really important. I think we want to make sure that, where explorers in business go, lawyers follow at a respectable distance.
Yeah. And are those conversations happening already? Are lawyers and other people sort of thinking about these sort of legal ramifications of
Absolutely.
exploration?
Absolutely.
That's interesting.
You know, and you've got people on both sides of the argument, people that argue we should be treating the moon as common heritage of mankind, and therefore all mankind should benefit from any activity on the moon. Yeah. And it's a reasonable position. We've got others that say, well, no, we don't want to restrict economic activity. And so those things are being discussed, and that discussion is going to get a lot hotter.
Yes, indeed. A couple more things. Nikki Bradford, this is a nice one for you. Nikki Bradford says, we would love to invite Andy Aldrin at Reaction Engines to the Reaction Engines site. There you go. To inspire our younger engineers and share your stories. This includes you, Dallas, and Susie, who's vanished. Okay, you're on. There you go.
I love Reaction Engines.
Reaction Engines do amazing stuff. So you'll know all about them.
And they've been at it. I think Alan Bond has been at this for decades. And I am fascinated by the technology, but more fascinated by understanding the business. And there is kind of, for decades, Reaction has been working on this technology, and there hasn't really, it's been a technology in search of a problem. Well, the problem is there now. The market is there now. And so I would love to come and talk to you.
Okay, Nikki, it's a deal. We're all going to come. The three of us will come together for a day trip. We'll bring our own sandwiches. You don't have to. We'll just be very quiet and have a little look. Yeah, I mean, I remember things that I think it was the Hotel Project, which was an early Alan Bond project from the 1970s about sort of hypersonic aircraft, and it's brilliant. Can I just, as a sort of final thought, your thoughts on sort of British, because here we are in the UK trying to inspire young people in the UK. Your thoughts on the British UK contribution to space flight at the moment?
Yeah, so it starts with what I said before. This is a magical time in space, and it's a magical time for those who have not been kind of front and center participating in space. The history of space was by the major powers and by astronauts and by big governments and big programs. That's all changed. Every government, every country in the world almost will be able to participate in space. We've gone from something like 40 countries with space programs 5 years ago, and we now have 80. So the opportunities are incredible. And the UK is kind of ideally situated because you've got such an incredible knowledge base in the country. You've got such incredible enthusiasm. You've got a great financial structure. And so I think the future for space in the UK, not, for commercial space in the UK, I think this is one of the places where you're going to see a tremendous amount of growth and a tremendous amount of opportunity. My only word of caution would be, you got to think about the markets. You got to understand what makes sense, because if it doesn't make sense, it ain't going to make dollars.
Yeah. That's a good point to leave. And I should point out as well as brilliant British engineering as well. The poster behind you, brilliant British science fiction as well. That you've got your Hitchhiker's Guide to the Galaxy, which I know for an awful lot of people was a sort of fuse lighting moment in their science careers, reading Douglas Adams. And so I know for you as well.
I never forget where my towel is.
Never forget where your child. There we go. On that bombshell. Andy Aldrin, a huge pleasure. Thank you so much.
Dallas, it's always wonderful talking with you.
I love talking to you. I always feel really inspired and motivated talking to you. And we're looking forward to having you back in the UK very, very soon, hopefully this year.